Okay, this segment is going to focus on qualitative techniques used for product idea generation. And so this segment is very different from some of the others in the sense that we're not going to worry about quantitative data or numbers to drive our decision-making process here, or to come up with new product variations or extensions. So we're going to use a series of techniques. We'll actually talk about 4 different methods that can be used to stimulate product ideas based on ideas we already have from the opportunity identification stage. So again, this section is a little bit different in the sense that we're not talking about perceptual maps, we're not talking about surveying customers, we're not talking about factor analysis, we're not talking about conjoint analysis, or the other quantitative techniques that are used to generate new product ideas, but rather what we're going to do is some brainstorming techniques, and we're going to talk about some different methods that we can use to just generate concepts or using words or qualitative techniques in order to generate new product ideas. This segment deals with qualitative analysis techniques, and so the idea of qualitative is that we can create product ideas based on different product features, but we will specifically not use numbers, measured numbers to illustrate or to characterize different attributes of a product. So qualitative by nature suggests that we're going to use some type of a verbal approach or some type of an approach that deals with describing in a verbal or word sense what's going on as opposed to from a numeric perspective. So there are a couple different ways that we can look at this, and dimensional analysis using checklists, using relationships and analogy, and also using a morphological technique as well is something that we can use from a qualitative or non-numeric perspective. So when we talk about a dimensional analysis, what we're thinking about doing is being able to describe a product and all the different features that it has associated with it. Sometimes we list these out kind of on a spreadsheet or on a piece of paper. We just describe the different features, and this takes a little bit of brainstorming and a whole lot of creativity to be able to do a dimensional analysis. Sometimes that, simply listing out features that you wouldn't normally associate with a product will generate a creative process where you'll come up with new ideas. So the idea of being creative when you're listing out dimensions is super important here to be able to get beyond what is normal, what is ordinarily expected. So the example that we'll look at takes into account the notion of a flashlight. So we know that people have a need for being able to see in the dark, and there are lots and lots of different technologies that actually produce light. But the question is, if we're going to create new form and a new type of flashlight, what type of dimensions does or could be associated with an actual light emitting type of a device that we might not otherwise think of? And so when we talk about dimensions, we're not talking about specific selling points that a consumer would come up with from an attribute standpoint, but we want to go beyond that. We want to think beyond the box, if you will. So certainly the weight of the flashlight, how heavy it is, but then other things like rust resistance. If the flashlight is being used in a high humidity, water-based environment, rust is certainly a problem. So using components that don't rust, length, size, color, the color of the light that's emitted, the color of the actual flashlight itself, the lens color, and so forth, water resistance, materials that are used in the product itself, into the flashlight itself, the styling, the ergonomics of it, how it's held, whether it's easy to hold or has a grip on it and such. Durability, so like could it, for instance, be dropped and still be okay? Shock resistance, heat tolerance. What if you're a fireman and you're going into a super hot, situation, but you need light? How can your product satisfy that particular need? Explosiveness, flammability. How about aroma? Does the flashlight have a smell or a fragrance of some type? Buoyancy, translucence, hangability. So, sometimes we want to hang up the actual device on the wall to store it. Rechargeability, flexibility or malleability, and compressibility. So these are all features or dimensions that we could brainstorm on, and we could think of a lot of different types of products, or variations of a product, through the different dimensions that are listed here. Now, again, keep in mind, none of these are ones, or few of these are ones that customers would actually think about as top of mind key attributes that would cause them to buy one product over another. However, all of these could be selling points that we could use as a company to market the product as different and unique from the competitors. Any one of these we could think of as having different levels or different degrees of. So we could vary those different degrees, and we can maybe find lots and lots of new innovative uses for a flashlight based on some of these very uncommon dimensions that we're thinking about. So, dimensional analysis is one of the qualitative techniques that we could use. Another qualitative technique is the idea simulator, or it's actually a checklist, which would be a list of products or a list of features, if you will, that can be we can ask questions about. So a checklist of questions that can be applied to a product can create a whole bunch of new ideas. So there's the Smalls Ideation Simulator checklist, for instance. It's a series of 112 different questions. The dimensions, like here's a question: can the dimensions of the product be changed? So can it be made smaller or longer or larger or shorter and so forth? That's a question. Regardless of what the product really is, we could ask, can we change the dimensions of the product? So that's one of the questions. Can the quality be changed? Here's a second question of the 112. Can we change the quality higher, lower, more or less, and so on and so forth? Another question, can the order be changed? So the order of operations, how you use the product, can we make a different process and therefore the product be used in a different way? Can different elements of time be changed as you use the product? Can things be automated? Can the product be used during different time of day or so forth? And if we do make some change expectations in time, does that change the product or how the product is used for the customer? Can the cause or effect be changed? So presumably you're using a product to fulfill some purpose. What other purposes could be used for our product? Or could I use my product in a different way, and by using it in a different way, fulfill a different purpose that the product actually has? Could the cause or effect be altered that we're using the product for, that, or from which the product was originally designed? Can there be a change in the character of the product, the features of the product, the brand of the product, and so forth? So a set of questions can be used and applied to multiple product concepts. And every time we ask a question, we pose a slightly different limit on the actual product that we are producing. And by doing so, again, we're adding a huge degree of creativity, and we're really, really pushing ourselves to think outside the box when we're thinking about new product ideas. You can think of dimensional analysis and checklist techniques like this as ones for products that do not exist, or ones that would be a stretch for the consumer, ones that the consumer might not necessarily think of on their own. There's also a checklist that can be utilized for industrial products. So can we change the physical or chemical products of the materials that are being used? When we think of processes, we might think of or ask the question if there are functions that are being done, and do they need to be done? Can they be skipped, or they could be dropped? Can we construct a new model or a new way of doing something? What about the power or the energy source that is being used? Can a different energy source or form of power be used to do this industrial process? Can standard components be substituted? Can we use a platform, for instance, a platform process where we can interchange different pieces of our industrial process for the product to be designed and created? Again, the order of the process, can we change that? Can the product be more concise? What happens if we do different, change different features of the product? Can we heat it? Can we cool it? What if it was cured, and so forth? Okay, so the idea of a checklist is that you have a series of questions that remain the same, but we apply the questions to different product concepts. And as we do this, we are stretching our imagination and our ability to create new products, thinking way outside the box sometimes. And a lot of times we're going to come up with a lot of really crazy ideas. With the dimensional analysis, with checklist analysis, with a number of these, we're going to think of products that are far-fetched and kind of unrealistic, but the process of doing this actually allows us to come up with ideas we otherwise would limit ourselves to not thinking about. Okay, so those are checklist concepts. There's also been some research by Goldenberg and Mazursky that talks about different templates that could be used to, again, think outside the box and think creatively. One of which is called the attribute dependency template. So we have different dimensions of a product or different features of a product, but sometimes you can think of one feature leading to another feature. So interactions between features, for instance. It's often the case that we have different product attributes or different pieces of the product that can be broken up, but they actually relate to each other, or they interact with each other. So creating a product that relies on the interaction of dimensions is the attribute dependency concept. An example here is the color of ink on a coffee cup that's sensitive to heat and can reveal messages if the coffee is either too hot or it can let you know when the coffee or the cup becomes cool. So, so for instance, Coors beer has a can that turns blue when it's cold. So that feature, the dimension of the can itself, is affected by the coldness of the beverage inside, which is a second dimension. So one dimension is causing a change in a second dimension, and it provides a benefit to the consumer. This is, again, it's a very creative, innovative way to think when you think about dimensions relying on each other to perform some type of activity or benefit for the customer itself. Another template for creativity by Goldenberg and Mazursky includes replacement. Okay, so the removal of a component and its replacement, like for instance, if you have an automobile, traditionally we have an antenna for the radio. Well, what if the antenna, instead of coming out of the vehicle as an antenna that comes up like a piece of metal or a rod of some type, what if the antenna was built into the framework of the car so that you didn't have to have that extra piece coming up out of your vehicle, but rather the actual antenna was built into the body of the automobile. So for a long period of time, there would be an actual antenna embedded into the windshield, for instance, of a car, and those two components would work together. Your windshield would obviously you'd look out of it. It's something you as part of the vehicle, but the integration of the technology for the antenna was built into that piece. So that would be an example of a integration of pieces where one is actually replaced by another. One dimension is replaced by another, and being able to use it that way. A third template for creativity is called displacement. Displacement. So if you create a product and you decide to modify a component so that the product itself changes or changes usefulness in some way. This might be a way to change a product, to create a new product, but you're displacing one dimension for another dimension. So here's an example of where if you have a laptop computer and you start taking pieces off of it like a disk drive. By taking the disk drive out of it, you can make the actual computer smaller. Maybe you even take out a lot of the memory and you rely on some cloud-based memory storage feature, which again makes the laptop smaller, less heavy. And so you're changing other dimensions because you're withdrawing or taking out features. So you're modifying the product itself, giving benefit to one dimension at the expense of perhaps another. That would be the idea of displacement. The last component, or the last template for creativity, is component control. Now, this might be a case where we, again, look at the interaction of dimensions or pieces of the actual product, and we look at how they interact with each other, and it may be possible that one of the internal components could be modified, could be with another internal component to create some external benefit that we find. So component control, added ingredient products, ingredient branding, and ingredient additions may be a source of this type of template to create some new product or benefit. Examples like toothpaste with teeth whiteners. So not only would a toothpaste maybe have a clinical need, but it also have a cosmetic benefit as well if a whitener was included in it. Suntan lotions with skin moisturizers. So the combination of components add benefits that build on top of each other. When you think of the internal components of the actual product and how they could grow with each other. Okay, so templates for creativity then again, so like the checklist is a standard set of procedures, if you will, that can be applied, or concepts that could be applied to lots and lots of different products. But these are all kind of outside the box, dimensional, kind of brainstorming, creativity techniques that we can actually use to create new product concepts. A third concept here in this idea of qualitative brainstorming, if you will, is relationship analysis. So specifically, we want to force combinations of dimensions that go together so that we can find additional relationships between the different attributes that exist. So there's a two-dimensional matrix concept. And then also a multi-dimensional or morphological matrix concept. With the two-dimensional idea or concept, what we try to do is build multiple purposes or multiple features that may otherwise not be related together. So an example here is like an insurance company that insures a person and an animal together. So if you're driving along in a car, you have an accident, a person might be covered, but other like pets and so forth might not be covered. But by adding on some non-related dimension like the animal, you're able to benefit or gain in two different unrelated dimensions. You're bringing them together to have some meaning together or reason together. Here's another example: household cleaning products, where we have the actual cleaning agent, the ingredients used, the objects that are cleaned. Okay, so like what can be cleaned with a specific set of ingredients, along with the actual tool or instrument being used to apply the cleaning agent. So we've got three different otherwise unrelated objects here, the types of containers that we use, what you're cleaning specifically, and the different the texture or the form or the how the cleaner is actually cleaned together or brought together. This is an example. This is a multi-dimensional way to bring lots of different attributes, and then we can cross-section each of these 6 attributes with the different types of, like, so for instance, I have for instrument used, we might have some handheld sponge that you'd use with a glove holding it, or you might have a wand and a stick, or you might just spray the cleaning product on and you might not touch it at all. There are 3 different ways to apply it. Then we talk about the different ingredients used. We can have a whole list of different ingredients used, and so on and so forth. So this is like a multi-dimensional type of an approach. Another example of a multi-dimensional or morphological approach would be the example of a new coffee maker. And if you break down the new coffee maker or a coffee maker or making coffee in general with the different steps, then we come up with lots of different ways we can create new products. So think of the heating process for heating water. So heating water is one component, though it's not naturally directly related to making coffee. I mean, you might heat water for lots and lots and lots of different purposes. One use of heated water would be to make coffee. So the heating process is one element to consider. And we have three different ways in which we can identify this process: through a microwave, through an open flame, or through some type of a heating element. Another step in the coffee maker process is adding coffee. So we can add coffee manually by hand. It could be automatically produced by the machine itself, some built-in measuring cup or cap. So we pour a certain amount of coffee in, and when it hits a level, then that's the appropriate amount. But the process of adding coffee is a step which could be accomplished several different ways. So now we have three different ways to heat water, and we have three different ways that coffee could be added. So now all of a sudden I can start brainstorming. What if I had used the bi-spoon method to add coffee, and it was a microwave unit that was heating the water? Okay, now I can start thinking about, well, what would my product look like? It'd probably be some type of an instant coffee, maybe, that I automatically put into a cup, and the cup goes in the microwave, and it's all done automatically that way. Or I could think of a bunch of other different products. What if I used a flame? If maybe in a camping situation where you don't have a microwave and you don't have electricity. So what if we didn't have electricity and we were in an environment where electricity was difficult to acquire? What are the different steps that I could take that lend themselves? Another step in the coffee making process would be filtering. Okay, so lots of different ways we can filter coffee, which is the process of pouring the water through the actual coffee, letting the coffee steep into the water, and then what emerges out is some type of a cleansed liquid that doesn't have a lot of little bits of coffee in it, but retains the actual fluid that has been seeping or sitting in the water for some period of time. So now we have another set of dimensions that we can use kind of with our other two, and we can like create lots of different product ideas now on new coffee makers. Adding two more characteristics of the process of doing coffee would be keeping coffee warm and actually pouring the coffee. Okay, so as we add features, or as we add different process steps, we can add different features. One step leads to the next, which leads to the next, and as we do process steps, we can come up with lots and lots and lots of different product ideas for a new type of coffee maker. This would be a morphological type of matrix, type of a step. We look at this as a series of relationships, though, between process steps, where one process step naturally provides opens doors, if you will, to the next process step on how that next process step can be done. Like if we don't have electricity, then having an automatic feed really doesn't make sense by adding coffee. But using some type of filtering system where we use gravity to draw water down naturally makes perfect sense. Keeping coffee warm, that's a whole nother issue. What if we had some thermal insulating technology which doesn't require electricity, but it's like a big thermos and it's able to keep coffee hot for a very long period of time? We wouldn't require electricity for that. So one piece of the process morphs onto or leads to other pieces of the process where new products can be created. The next step then would be, or one more example, one last example of qualitative techniques would be ones by analogy. Now, an analogy is where we take a process or a product that is somewhat similar to our problem, that's solving our current problem maybe, and we use it as an example to create our new product. So like for instance, during the 1980s, the VHS and beta analog tapes were created for being able to watch movies at home on a machine. During the 1990s, the DVD or compact disc technology was created, which used a laser to read a disc, which took from digital form, transformed the digital form into something that we could watch on TV. So when we're looking at DVD sales, for instance, in the early 1990s, one of the comparisons that could be made was how this new technology would emerge by watching and observing and studying how the VHS and beta technologies emerged in the 1980s. It was like an analogy. It was a similar product need being met, which was watching movies at home. But the technologies were changing. The technology changed, and so in order to be able to forecast and analyze how the new DVD and laser technology would be accepted in the marketplace, we're able to look at that growth, anticipated growth and expected market through the lens of the VHS and beta technologies. So an analogous product is where we look at a possible solution through the eyes of another product. So here are three examples. One is an airplane food system. Now, in an airplane food system, the food needs to be prepared by passenger portions, already portioned out. It needs to be something that can be heated up or cooked in a small area. And imagine if you had in a small apartment in a big city and you didn't have a lot of space to store food. You didn't have a lot of space for big bulky appliances, but you had the need of cooking a meal or having dinner and so forth. A lot of the same problems that an airplane would have in preparing food, a apartment dweller in a very small space would have similar types of problems. So you can use the analogy of preparing food in a plane to preparing food in a small apartment. So again, you think about like comparing one to the other. Amusement park lining people up. Park designers have been inspired in the past by watching how cattle is herded and trying to identify the most efficient way to move people like we would move cattle in a field or through a barn or through a series of gates, because that's essentially what we're doing in an amusement park. A bicycle is somewhat similar to driving a car in the sense that you have to see what's in front of you. You have to be able to move left and right. You have to be able to speed up and slow down. There are a lot of analogous ideas or concepts associated with, being able to drive a car or drive a bike. Okay, so analogy provides us another opportunity then for selecting or creating new products. So when we think about selecting products this way, we want to be able to select products that truly stand on their own, that are real, true products that we could stretch a little in a creative sense to apply to the product that we're now looking at. We should think about products that that have concrete solutions that actually work, that things that we can observe, for instance. So it should be something happening. It should be a process of change. It should be something that we can watch. Something also, one last point is that an analogous product is typically one that we're familiar with already. So that we really understand how the old process is being used and done and committed to, so that we can apply those concepts to the new product that we're actually looking to create. Okay, so this is a little deviation from some of the other material in the sense that this is all qualitative product idea generation notions. This is not opportunity identification where we did some brainstorming in other segments. This is where we're looking at new product ideas. We're generating product concepts here in this section, but we're not using a quantitative method. We're using qualitative methods, one of which is dimensional analysis, and we use the idea of a flashlight as it has many, many, many different dimensions that you might not normally think would be in a flashlight, but ones that we can think very creatively. And by brainstorming outside the box, we can come up with lots of new ideas for a flashlight. We had checklist ideas. Now, Small's ideation checklist is one example, for instance, of a checklist, which is essentially a series of questions. So we ask a series of questions and then apply those questions to the product concept that we're trying to develop. And from this, we're going to come up with a lot of new product ideas. We also looked at different templates for creativity, the attribute dependency template, replacement, displacement, and the component control template. Again, these are kind of relational types of things that are going on between product components that maybe work with each other in order to create some new benefits. We also looked at this idea where different dimensions of the product can lead to new product ideas from a relationship perspective. There's the two-dimensional kind of technique where we take two objects that may be unrelated and we tie them together and make a relationship between them through our product or our service. There's also the morphological process where we take different steps or different components of the product and we morph them together in new and unique ways. So we had the coffee maker example with that. And then finally we had the analogy or process of analogy where we can take some unrelated product that we know has something to do with or some corresponding application that makes sense for what we're doing in terms of a new product. So we might look like in the 1980s we had the VHS and beta analog tapes. In the 1990s we had DVDs, Blu-ray, lasers eventually. In the digital field for watching TV or watching movies, these are two very different technologies and two very different products, but one really describes the other in terms of what it does for the customer. We had some other examples as well from an analogy perspective dealing with food systems in small places, amusement parks, and also the bicycle example. Okay, so this wraps up then the discussion on qualitative techniques that could be used to create products.